Hi everybody. In this lesson I want to look at a few more examples of some complex rational expressions. So here I have a fraction of fractions, algebraic expressions, and you'll notice I have the same problem right over here next to it. We're going to use both methods to simplify this so you can see the difference between them. Okay, so the first technique is to go ahead and just treat this complex rational expression as a big numerator over a big denominator. Simplify the big numerator by getting a common denominator. Combine these two fractions into a single fraction. Do the same thing here in the denominator, and then you'll have a fraction divided by a fraction that you can just invert and multiply. All right, so you'll notice here that here's a fraction that has a denominator of y minus 3. I don't have a y minus 3 over here, so I'm going to have to multiply here by y minus 3 over y minus 3 so that I get the y minus 3 there. Now likewise, there's a y plus 1 in this fraction that I don't have over here, so I'll need to multiply here by y plus 1 over y plus 1. Okay? Notice how I had the problem set up initially by leaving some space to add in what I needed to get the common denominator. So that's a good practice when you copy these down out of your textbook. Leave a little extra space if you're going to use this method. All right, so do the same thing in the denominator here. I'll multiply here by y minus 3 in both numerator and denominator, and this fraction by y plus 1. All right, so now I've got this combining these, I've got 2y plus 2, that would be this numerator, plus the y minus 3, and that's all over this common denominator, y minus 3 times y plus 1, and then that's all over this other set of fractions that I'm combining. This would give me 3y minus 9 right here when I distribute, plus 4y plus 4 when I distribute the 4 to that numerator. And that's all over this common denominator, y plus 1 times y minus 3. All right, so from there I'm going to go ahead and write this as this numerator here. What is that? 3y minus 1 all over this denominator, y minus 3 times y plus 1. And I'm going to invert and multiply and combine in one step. These problems can be kind of cumbersome, but this is one place that you can easily combine a step. I got y plus 1, y minus 3 in the denominator, so that's going to become the numerator. And then this right here I can combine. That's going to be 7y. 3y and 4y is 7y, and minus 9 plus 4 is minus 5. Now remember, that's a factor. I'm going to put parentheses around that just to remind myself. And then you'll notice that when I invert and multiply, these y plus 1s, the y minus 3s, they're going to cancel. So I just get 3y minus 1 all over 7y minus 5. Okay? Now I'm going to do the exact same problem using the second technique for simplifying, and usually this second technique is actually easier. And what you do is you look at the big numerator and the big denominator, and you want to multiply by the least common denominator of all the little fractions. So you look at all of these little fractions in this complex expression, and you'll notice that there's a y plus 1 and a y minus 3, and that would cover everything. So I'm going to multiply by y plus 1 times y minus 3. And again, you want to think of that as being like over 1 for each of these, because what you want to do is multiply it over, right, this is going to multiply that numerator, and you see that when you do that, this y minus 3 is going to cancel when I distribute there. So in doing this, let me draw a line here, I'm going to get, when I distribute all the way over, I'm going to get 2 times y plus 1 times y minus 3 over y minus 3 times 1. So you see these y minus 3s are going to cancel. So I can just write, hopefully you can do that in your head, and you may want to write it out a few times just so you get used to what's happening there. But I can just write 2 times y plus 1. And then I also have to distribute. Right, I distributed to this first term, now to the second term. So I distribute to the second term, I'm going to get 1 times the y plus 1 minus 3 over the y plus 1 times 1. So here the y plus 1s are going to cancel. I'll just get 1 times y minus 3. Okay? And then I do the same thing in the denominator. So I'm going to take and distribute this whole expression right here over to this term. And you see the y plus 1 in the denominator is going to cancel that. And I'll be left with this 3 times the y minus 3. And when I distribute to the second term, you see the y minus 3's will cancel. And I'll be left with the 4 times the y plus 1. Okay, so the beauty of this method is that in one fell swoop you're able to eliminate all of those little fractions. You get rid of all the denominators, you completely get rid of the complex fraction, and now you can just simplify this, right? 2y plus 2 plus y minus 3, which should look familiar, right? That's really that numerator right there. And 3y minus 9 plus 4y plus 4, again that's this numerator right there. And so when I do that, my final answer is going to be 3y minus 1 on the top over 7y minus 5 in the denominator. Okay, and of course we got the same thing there. All right, let's do one last problem here just to illustrate how easy this second technique can be. Here I've got y squared over y squared minus 9. And you notice that y squared minus 9 is a difference of squares. You should recognize that that's going to be y plus 3, y minus 3. And I've got a y plus 3 here. And so if I look at this whole numerator and this whole denominator, you'll notice that the common denominator, the least common denominator of all these little fractions, well, there's a y plus 3, y minus 3. And that encompasses the y plus 3 here, and the y plus 3, y minus 3 here, and the y minus 3 here. So if I were to just multiply by y plus 3, y minus 3, over y plus 3, y minus 3, of course anything divided by itself was 1, so I'm not really changing the fundamental, any fundamental nature of the problem there. So this is going to give me, when I take and distribute this over here, then this whole y plus 3, y minus 3, that's going to cancel the y squared minus 9. And I'm just going to get the y squared right here. And then when I distribute it here, you can see that the y plus 3 will cancel, and I'll be left with the negative y times the y minus 3. Okay? So let me correct my color there. So minus y and times y minus 3. And then I'll do the same thing in the denominator. When I distribute this over to this term, this is going to be in the numerator, and that's going to exactly cancel the y squared minus 9. So I'm left with a y, and here's the minus sign, and then the y minus 3's are going to cancel, and I'll be left with just 1 times y plus 3. Now notice I'm being careful to put parentheses around that, so because I do have to distribute that minus sign. So this is going to give me y squared minus y squared plus 3y in the numerator, and this is going to give me y minus 3 in the denominator. So in this case, the y squareds cancel, the y minus y cancels. I end up with 3y over negative 3, and then the 3's will cancel, and I'll just get a negative y. So that simplified a whole bunch, didn't it? Okay.